Hello everyone, let's solve this problem, snake in a matrix. So this problem is like easy problem. So if you know the basic programming language and if you know the basic implementations, then you can solve this problem very easily. So I recommend you like at least try for at least 20 minutes. If you are unable to solve, then you can come and watch the video solutions. So first let's understand the problem statement. There is a snake in an enclosed matrix grid and it can move in four possible directions, right? Each cell in the grid is identified by the position grid of ij equals to I into n plus j. He's saying that every grid has some sort of position. The position is defined as I into n plus j. So if you see here 0 1 2 0 1 2 n is equals to 3, right? So our formula is I into n plus j, right? See, I into n plus j. So if you perform this operation 0 into 3 plus 0, 0 into 3 plus 1, 0 into 3 plus 2. If you do this, we will end up with 0, 1, 2, 3, 4, 5, 6, 7, 8. In this way, we will end up this way, right? So first we will try to build the grid. After building the grid, the snake starts at cell 0 and follows a sequence of commands. So he's telling that at cell 0, my cell will start. Cell equals 0 means I is equals to 0 and j is equals to 0. At this position, it will start. And at each command, it will go either up or right or down or left. Now simple, right? Now let's consider you are having x comma y, right? If you are going top, what happens? Your x increases by 1, x plus 1 comma y. Sorry, it decreases by 1. X minus 1, right? And if you are going down, it will be x plus 1 comma y. And if you are going toward the right side, it will be x comma y plus 1. And if you are going left, then it will be x comma y minus 1. This is the simple 4 steps are followed. So this is my up, right, down, and this is my left. So these are the operations. We need to return the position of the final cell where the snake end up after executing the commands. He gives the commands, right? After executing all the commands, at what position your snake ends. So this is the question, right? Now if you see, the input is generated such that say snake will not move outside the boundary. So definitely it will not go outside. So it is 3 cross 3 grid, right? If you are at this position, he can't say you should go down. If you are going down, you are going out of grid, and this scenario is not possible. So whatever the commands he is giving, it will be in the input. So don't worry about the special scenarios. Now we will starting with 0 comma 0. First step, we have built the matrix x equals to 0, y equals to 0. Now as we discussed there, right, x equals to 0, y equals 0, and this is my size. If it is up, then we are doing x minus 1. X minus 1. If it is right, it's y plus 1. If it is down, x plus 1, and if it is left, y minus 1. And at every command I am putting the if else conditions. And finally we are incrementing the I. And at v of x comma v of y, we are returning because we want the final index to be stored. So here if you see, the time complexity will be order of n into n, most probably, like number of comments, order of number of comments. And the space, we are using extra space, which is a vector, we are using that. So it will be the size is 10 only, so it will be 10 into 10 extra space. So I hope you learned something new. So if you learned something new from this video, I think if you learned something new from this video,